Good day, everyone. My name is Hyp² Daniel, and I'm the tutor for today. Please do well to subscribe and follow us across all social media pages at Goddam School of Mathematics. In today's class, we'll be looking at the topic Pythagoras Rule. It was Professor Pythagoras who discovered the relationship between the sides of a right-angled triangle. So first, we look at what is a triangle, what is a right-angled triangle, and then what is the relationship postulated by Professor Pythagoras between the sides of a right-angled triangle. So first, a triangle is a polygon with 3 sides and 3 angles. So we have 1 angle, 2 angles, and a 3rd angle. So a triangle has 3 angles. This is the first side, this is another side, and this is another side. So this makes this a triangle. A triangle is a polygon with 3 sides and 3 angles. Now, what then is a right-angled triangle? A right-angled triangle, first, is a triangle, so it has 3 sides and it has 3 angles. But then a right-angled triangle is a triangle that has one of its 3 angles to equal 90 degrees. Now, that angle that is 90 degrees is called perpendicular angle. Or right angle. It's of this shape. So this angle here is called perpendicular angle or the right angle because it is an angle at 90 degrees. Then if you draw a straight line to join these two lines, then it becomes a right angle triangle, and you can see it has 1, 2, and 3 angles, in which one out of the 3 angles is equal to what? 90 degrees. Now, Professor Pythagoras then looked at the right angle triangles and they began to name the sides of a right angle triangle. And they said that the side opposite, the side facing the right angle or the perpendicular angle is called hypotenuse. It is also the longest side of the right angled triangle. So we can then say that the longest side of the right angled triangle is called hypotenuse, or the side that is facing the perpendicular angle or the right angle is called the hypotenuse. Right? Now, if I have my angle theta here, for example, now the side facing the angle, the side facing the other angle, which is the angle theta now, is called opposite. So if I have a board or a stick facing me now, I say that the board is in opposite direction to me, right? So the side facing the angle is in opposite direction to the angle. So this side, which is facing this angle theta, is called opposite. Now, the opposite side is relative. It is not stationary. It is not stationary. This side is always the opposite side. If my angle, let's call this beta, for example. So if the angle is at this point, now this side will be the side facing this angle. So at this point, for this angle beta, this side will be the opposite for angle beta. Why this is the opposite for angle theta? Now, the side which is on the straight line with the perpendicular angle is the adjacent. It's called the adjacent, which means that if this is the opposite side for theta, this other side will be the adjacent for theta. So the hypotenuse is always the longest side of the right angle triangle, and it's also the side facing the right angle or the perpendicular angle, right? While the side facing the angle, the other angle, is called opposite, and the third side is called adjacent. So if the angle is at this point, theta, right, this side facing the angle is opposite, right? And this side will become adjacent for theta. If the angle is at this side, which you call beta, right? This is the side facing the angle, which is beta, right? This becomes the opposite for beta, and this side becomes the adjacent for beta. Now, what does Pythagoras rule state? What is the relationship postulated between the sides of a right angled triangle by Professor Pythagoras? So Professor Pythagoras postulated the Pythagoras rule, which is also called the Pythagoras theorem, which states that the square of the longest side of a right angled triangle, the square of the longest side of a right angle triangle is equal to the sum of the square of the two remaining sides. The longest side is the hypotenuse, right? If this is our angle, this is opposite, and this is adjacent, right? So Professor Pythagoras then states the rule to say the square of the longest side, which is the side facing the perpendicular angle, which is hypotenuse. So if I square hypotenuse, it says that the square of the longest side of a right angle triangle is equal to the sum of the square of the two other sides. That is, when I square opposites and adjacent, which means to say that hypotenuse square is equal to opposite square plus adjacent square. Now, let's solve an example using the Pythagoras rule postulated, right? So we have an example. This is a right angle triangle. This is the perpendicular angle. So this is the side facing the perpendicular angle, which is the hypotenuse. So we say the hypotenuse is what? X centimeter. So we say hypotenuse is what? X centimeter, which is what we are finding. And then this is the angle. This is the side facing the angle, which is the opposite. So we say opposite is equal to what? 3 centimeter. And this is the what? This side, which is on the same straight line with the right angle triangle. We say adjacent is equal to what? 4 centimeter. Now, using Pythagoras theorem or Pythagoras rule, right? We say, which says that hypotenuse square is equal to opposite square plus adjacent square. So you already know that our hypotenuse is x. So the square of x is x square, which is equal to opposite is 3, and the square of 3 is 3 square plus adjacent is 4. The square of 4 is 4 square. So we have x square equal 3 square is 3 times 3, right? Which means we multiply 3 twice plus 4 square is 4 times 4. So we have that x square is equal to 3 times 3 is 9 plus 4 times 4 is 16. So we have that x square is equal to 9 plus 16 is 25. Now, at this point, to find x, we have to eliminate this square, because what we are looking for is x, not x squared. So for us to get x, it means that we have to eliminate this square. And for us to eliminate square, we have to find the inverse of square, which is square root. So we take the square root of x squared to eliminate square, and according to the rule of equation, whatever happens to a side must happen to the other side. So if I want to eliminate square here, and I take the square root of x raised to power 2 to eliminate square, I must also take the square root of 25. Because I had introduced square roots to the left hand side, I must also introduce square roots to the right hand side. So we say, take the square root of both sides. So we have the square root of x raised to power 2 is also equal to the square root of 25, which makes my equation balance. So at this point, this square will cancel this square root. So we have x left, and we have x is equal to what? The square root of 25. The square root of 25 simply means what number will I multiply twice to get 25? And that is x equal to what? 5. 5 is that number that I'll multiply twice to get 25. So at this point, we say my hypotenuse is equal to what? 5 centimeter. Now, look at this example. If you look at this shape, this is the only perpendicular angle in this shape. So now, and if you look at this, if you trace this line like this, downward, up to this point, like this, you will discover that this is a right angle triangle. Right? And if you look at this shape like this, it is also another what? Right angle triangle. Now, let's call this, let's say A, B, C, and D. Now, triangle ABC. In triangle ABC, right? If you look at this, we have Y, we have BC is 8 centimeter, CD is 12 centimeter, right? So, and this is the angle. This is the side facing the perpendicular angle. So from triangle ABC, we know that hypotenuse is equal to what? 7 centimeter, right? Opposite is equal to Y centimeter, and then adjacent, which is BC, is equal to 8 centimeters, right? But then in triangle ABD, our hypotenuse, which is the side facing the right angle triangle, which is AD, hypotenuse is equal to X centimeter. So in triangle ABC, we have to find opposite. In triangle ABD, we have to find hypotenuse. So, and then this is the angle. So this will be the side facing the angle. So we know that opposite is equal to what? Y centimeter. And then adjacent is equal to, which is BD. So the adjacent for triangle ABD will be 8 plus 12, which is from this side to this side, plus from this side to this side. And that is what? 20 centimeter. Now, for you to use Pythagoras rule, you must be given at least 2 sides, right? So, if you look at triangle ABD, we only have one side. X and Y, which is hypotenuse and opposite, are unknown. So we cannot use Pythagoras rule for triangle ABD yet. But if you look at triangle ABC, right, we have hypotenuse, we have adjacent, which is 2 sides already. We are only looking for what? One side. So we can then use Pythagoras theorem or rule for triangle ABC. So we say, using Pythagoras rule, in triangle ABC, right? We state that hypotenuse square is equal to opposite square plus adjacent square. Now, in triangle ABC, we know that hypotenuse is 7, so the square of 7 is 7 square, which is equal to opposite is Y. Square of Y is Y square plus adjacent is 8. Square of 8 is 8 square. So we have that 49 is equal to Y square plus 64. So we collect like times. Right? We have that 49 oh, sorry, hypotenuse is 17, not 7. Apologies about that. The hypotenuse for triangle ABC is 17 centimeter, not 7, right? So we have 17 square equal Y square plus 8 square, right? 17 square is 289. So we say 289 equal y square plus 64. Now if you collect like times, we have 289 minus 64 equal y square plus 64 minus 64. Eliminating 64, we have 289 minus 64 equal y square, right? So this is 225 equal y square. Now we take square root of both sides to eliminate the square. Since we are looking for y, not y square, we have that square root of 225 equal to square root of y square. So the square will eliminate the y, the root, so we have y equal square root of 225 is 15. So our y is what? 15 centimeter. Now in triangle ABD, we now know our opposite, which is y centimeter, to be 15 what? Centimeter. So we can now find x, which is our hypotenuse, right? We say hypotenuse square, which is now in triangle ABD, right? Hypotenuse square, which is x square equal opposite now is 15 square plus adjacent is what? 20 square. So we say x square is equal to 15 square is 225 plus 20 square is 400. So we say x square is equal to 625, right? So the next thing to do is to take square roots of both sides. To eliminate the square for x, since we are looking for x, not x square, so we have the square root of x square is equal to the square root of 625. This square will cancel the root. We have x equals square root of 625 is 25 centimeter. All right. Thank you for watching the video. If you don't understand anything, please drop your question in the comment section and I'll be willing to respond to you ASAP. Please like and share so that other people can learn too. Don't forget that Brother Maths Quest happens every Saturday where we ask questions based on the topic talks for the week, right? And then two people will be able to win 5,000 naira for themselves. The questions are definitely taken from the topic posted on our YouTube channel and on our Instagram channel for the week. See you on Saturday. See you in next class. Bye for now.